All right. Good morning, everybody.
Good morning.
Good morning.
Morning.
Good morning.
All right. Well, my plans for today are to talk about PA2 and then talk about the new assignment PA3 and then talk about the 2 ODPs this week and then discuss the midterm and then go on to talking more about bash scripting. So if there's anything you want to talk about before we get into all of that, feel free. All right. Well, let's talk PA2. So PA2 is finished and I've posted grades in Canvas along with some feedback for most students. So if there's any point deductions, if you did not get 100%, you should have comments in Canvas explaining what the deductions were for. If you got 100%, you may still have comments in Canvas talking about aspects of your code, things that I saw that either seemed noteworthy, or maybe something you were doing one way that I thought there was a different way you could do, or something that maybe wasn't quite right but didn't cost you any points. So definitely make sure you look at the comments in Canvas for any of these assignments, and see what feedback I give you. And if you have any questions about grading or comments or anything like that, you definitely want to come to office hours and we can go over your code and the feedback I gave, and I can, explain if I said there was a problem with the makefile and you don't see a problem with the makefile, we can look at your makefile and I can tell you what I saw and so on and so forth. So definitely do that. PA2 is a really good kind of large scale, multifaceted C assignment. And since 222 in winter is all about C programming, and we're not really going to spend a lot of time, learning C syntax and brushing up on basics, PA2 is really kind of a good checkpoint to say, how comfortable am I with C? Was this a pretty straightforward thing to do once I knew the pieces, or did I barely get something that would compile and I had to cross my fingers to hope that it would work? That's an important thing to know. And if you don't feel after PA2 very confident about C, we should talk about that, and we should figure out what you can do between now and winter to help you become more confident and get more practice and so on. And in 222, we're going to spend a lot of time talking about pointers. So if you're kind of sketchy on pointers, that's probably okay, because that's, a separate topic and it's not something we do deeply in 121, and it's not something we've done a lot of this quarter. But on general syntax, on passing command line arguments, on using fgets and scanf, and parsing input and loops and conditionals and all of that stuff, that's the stuff you want to be pretty solid on at this point. So as far as PA2 itself, so a number of students came out with 100%, right? Just perfect code, worked great, followed the spec, and that's great. And there's not a whole lot to say about that. Some students had code that worked the way it was supposed to work, but still lost points for things like makefile issues, or the functions that they used to build PA2 weren't the same behaviors that were specified in the assignment, or the comment block at the top of each C file was missing, or things like that. So even if your program, behaved correctly, even if you ran it on the sample input and you got the correct output, right, that does not mean that your assignment is 100% correct. And so there were some deductions in those cases. And there should be explanations for what those are. And then there's cases where code was working correctly, but people may have been doing more work than was needed, and that doesn't cost you points, but it's something I noted in some cases. For example, we have this is alpha function, which tells us whether a character is a letter or not. And some people took the character and compared it to the ASCII codes for an upper and lowercase a and z to see if it was a letter. You can do that, and if you enjoy the challenge of doing that yourself, that's a good exercise. But if you weren't seeking that challenge, right, you could have just used the is alpha function. To upper, we pointed out, if you give to upper an uppercase letter, it does no harm. It just gives you back the letter. But some people check the ASCII code to see if this was a lowercase letter before calling to upper. Nothing wrong with that. It's just extra work. And like I say, if you wanted to do that just, for practice, that's great. But if you thought that was necessary, right, you should go back and look at the manual page for to upper in this case and see what it says. And so there were those kinds of things. When we read keywords from a file, we said we can use fgets because the way that the keyword file was arranged was one keyword per line. And fgets reads in one line at a time. So it's a perfect function to use. Use fgets, chop off the new line, convert to uppercase, and save it in your array. But some people read the keyword file one character at a time, and then looked for the new line and built up a string as they were reading. And then when they got to the new line, put in a null terminator and then copy that, and so on and so forth. And again, if that works, that's fine. But in some cases, that was so much code that there were errors in there and the keyword file was not, being processed correctly. And, we talked about using fgets. We wrote that out in sample code. And if you chose to read, one character at a time and basically write fgets yourself for practice, right, or as an exercise, that's okay. But if you don't understand what fgets does, that's something you definitely want to go back and look at. Come to office hours and ask, or ask in class, or take a look at the manual pages and make sure you know how to use this, because all of these functions that are available in C, right, they save us from having to do things ourselves over and over again. And so it's important to understand those functions and how they work. And then there were cases where PA2 just wasn't doing what it needed to do. For example, when you read the keywords, you need to make sure there's no new line at the end, because when you get a word with get word, it's not going to have a new line at the end. And if you compare, hello to hello \n, it's not going to match. And so in some cases, that was what was going on, and no keywords matched, and all the tallies came out to be a 0. And I told you in the beginning that when I grade PA2, I'll actually grade your individual functions. So if I ran your program and all the tallies came out to 0, then I started taking each of your individual functions, linking them with my own test programs, and testing them to see if they worked. And if keywords didn't look like it worked, then I went through the code and tried to find what the problem was and talked to you about that. But that's exactly the process that I was encouraging students to do while they were developing this program. Write your read keywords function, and then write a test program and print out the keyword array and make sure that it looks correct. And if you do that and you see a new line at the end of each one, it immediately jumps out like, hey, there's an extra character here. Oh yeah, I'm supposed to do, string bracket, string length -1, set that to a null terminator, and so on. So that's partially, maybe people not in class, because we've got, a quarter of the class not showing up. And it may be, you know, just information overload because there's a lot that we talk about, right? It's 125 minutes twice a week. Or not understanding what I'm saying and not feeling comfortable asking questions about it. So, I mean, it could be a lot of things. But again, you know, if you feel like you didn't know how to do this assignment, or you don't know what's wrong with what you did or something, come and talk to me one-on-one in office hours, and we can figure it out, and go forward from there. So this is the last big C programming assignment for this course that I'm planning. The future assignments are going to be Bash. So like I say, this is an important one to try to make sure you understand what you did, and if it wasn't what you wanted, right, how to correct that. Let's see, what else can I tell you about PA2? So I think the most common issue I saw people running into were issues around my get car or get word. And those had, you know, really specific behaviors that had to take place. And I think that maybe in some cases people were working on those and weren't able to get them to work, and it stopped them from being able to test their other code. And this was where, you know, we talked about, if you don't want to deal with my get car and get word, use fgets instead of get word, right? Make yourself a simplified version of get word that just reads, you know, one line, and run it on a test file where each word is, you know, on its own line. Chop off a new line, and then you can at least, you know, have a way to ingest words from a sample main program and test your tally, and test your read keywords, and test your display results. And there's a number of small mistakes I saw, like not printing all of the keywords and display results, printing one too few or one too many. And, you know, if you run a test program, it should jump out to you if you test this with 3 keywords, and at the end it only shows you the tally for 2 keywords, there's a problem. If it shows you the tally for your 3 keywords and then shows you a 4th tally for some gibberish word, there's a problem. And so writing the program is part of the problem. So understanding the assignment is the first challenge. Figuring out algorithms is the second challenge. Writing the program is the third challenge. Debugging the program is the 4th challenge. But then the last part is testing it, right? Which means running it against a lot of test cases and making sure that it does everything right. And that, of course, you know, may involve going back to more debugging, or going back to changing the algorithm, or going back to trying to understand what the assignment is saying. So it's not just a monotonic process, but each of these steps takes time, right? And so this is another reason where if people are starting the assignment 2 days before it's due, there's probably not enough time to get through all those steps. Those are fundamentally different processes. And I don't know how often people are pushing to Git, but just based on Git logs, a lot of people started this 2 days before it was due. And that's just really not giving yourself enough time. So if your grade on this was not what you were hoping for, my suggestion is use that as a opportunity to make course corrections, right? To look at how you approach this assignment and what worked well and what could have worked better, and maybe find different ways to go about the assignment. And again, you know, broken record here, come and talk to me, right? And we can talk about your particular approach to working on large programming assignments, and see if there's, you know, something different that might work better for you, and so on. It's also a good idea when you're done to go back and reread the assignment, and you know, maybe go through with a highlighter and mark off the important parts that you see in the assignment, and then compare that to what you're actually submitting. And, you know, if it says the program has to be named index and you call your program main, that's going to cost points. If it says that, you know, you need to have a block of comments in the beginning of each .c file with your name and a description, and you don't have that, that's going to cost points. All right, so any questions on any of that? All right, well, let's talk about PA3. So PA3 is posted on Canvas, and it's due a week from Friday. And this assignment, unlike PA2, this is really not a 2-week assignment. This should be doable in a week. But we have midterms this week, and I knew we'd be spending today talking about the midterm and PA2 and so on. I didn't want to have you try to squeeze this in with everything else. So I'm giving you, you know, almost 2 weeks for this assignment. It's probably not going to take more than a week, probably not going to take more than a few days. I actually have one student who's already done this and turned it in. But it's going to be a bash assignment, which means if you've never done any of the bash scripting that we started talking about, that's going to take some getting used to. Bash has its own syntax. You're going to have different ways of debugging your code. Bash is not compiled, so there's things you will do that, you know, like you might misspell the name of a variable, and you'll never get a message from bash saying, hey, you misspelled this variable name, because we don't declare variables. So it's a different feeling from C. And even if you are a very good C programmer who can develop C code very quickly, bash may be a different experience at first. So again, you know, don't leave this till the end. If it's only going to take you a day to do this, I would say do it today, you know, or tomorrow, or maybe on Saturday, you know, and get it done and out of the way. So the program itself does something you're familiar with. It's another version of the stick game. So this was PA1, stick picking game. But with some differences. And so you need to pay attention to the differences from PA1. And some of these differences are designed to make your life easier, right? So what does this game do? Well, so you start off with an initial pile of sticks. You take turns pulling sticks from the pile. Each player is allowed to take 1, 2, 3, or 4 sticks. So not just 1, 2, or 3, but you can take 4 sticks, and whoever picks the last stick wins. So that's one difference, right? You can take up to 4 sticks. When you start the game, you can either say stick, which will ask you, once the program starts, how many sticks would you like to play with? So that's a runtime input. Or you can say stick followed by a number, that's a command line input, and the game plays with that many sticks. So if you say stick 100, it just starts playing with 100 sticks. If you say stick, it says how many sticks do you want to play with, and I could type in some number. So that's different. You need at least 5 sticks to play the game. If the person tries to play with 4 sticks or 2 sticks or -1 sticks, you can print a message saying, hey, you need at least 5 sticks, and just exit. You don't have to ask them again. In fact, you're not supposed to ask them again. Just print a message and say, you know, please pick at least 5 sticks, and your program exits. So that's another difference. Next difference, the computer always goes first. PA1, the user got to go first. PA3, the computer goes first. Next difference, if the user is supposed to type in a number, an integer, you can assume they are typing in an integer. So you don't need to check for things like 3 haha or cool or 2.5 or something like that. So when is the user supposed to specify an integer? If they're saying how many sticks to play with, and if they're saying how many sticks they want to take. So you can assume those entries are always valid integers. So that simplifies your code quite a bit. Remember in PA1, we had to do an scanf, we had an ampersand extra and with the %s and all this stuff. None of that stuff here. All right, on the user's turn, it removes the number of sticks the user specified. On the computer's turn, it uses an algorithm to decide how many sticks to remove. At the end of each move, it should print out the pile of sticks followed by the number of sticks in parentheses. So that's the same as PA1. When it asks the user how many sticks to take, if they put in a number smaller than 1 or bigger than 4, ask them again and keep asking them. Don't time out after 2 incorrect answers. Just keep asking them until they put in a value between 1 and 4. So that's different from PA1. And again, you don't have to worry about, they type in, a word or something that's not an integer. You can assume they're typing an integer. Just check the range, make sure it's at least 1 and it's no bigger than 4. All right, the algorithm is just like PA1, except we're going to use n mod 5 to decide how many sticks to take. So if there's 12 sticks in the pile and it's the computer's turn, the computer should take 2 sticks because 12 mod 5 is 2. And we have a mod operator in bash, it's the %sign. So just like in C. And then just like in PA1, if n mod 5 is 0, we're not allowed to say take 0 sticks. So the computer will take 1 stick in that case. All right, other requirements must be written in bash. So this has to be a bash program. You must follow the bash guidelines given in Canvas. So we'll take a look at those in a little bit and make sure what exactly this means. But there's a how-to guide on Canvas which specifies what you are allowed to do in bash. It specifies exactly how you can do bash if statements, bash while loops, bash conditions, bash arithmetic. And you need to follow those guidelines. And if you're an expert at bash and you know all these cool tricks for doing things differently, I apologize for forcing you to do it this particular way. But I need to do that because I need to assess whether or not you actually understand how to use these statements. So we'll pull down that guide and we'll go through it and we'll stick to that when we do sample code. And we'll do a bunch of sample code today. All right, you need a comment block in the beginning of your script, which means a block of comments describing your name, the course, the date, the assignment number, and a synopsis of what this script does. So I gave people a lot of slack on PA2. I said I wanted a complete description of the function in the beginning. And I got some descriptions like function that returns an integer, which is a true statement, but that's not really a complete description of what my getChar does, right? My getChar calls getChar to read from standard in, loops until it finds something that is a letter, a space, or end of file, returns an end of file as is, returns any white space as a space, and returns a letter as an uppercase version of the letter. It also returns an int. It's a function that returns an int, but it's more than that, right? So I want a good description of this assignment in your own words in the beginning of your script. And you also want to make sure that before that block of comments, the very first line in your file is this: $! Exclamation mark /bin/bash. No spaces in here. And that's the shebang. That's the thing that says, hey, the script should be run with the bash interpreter. And then submission is exactly the same as usual. Make your script named exactly stick, S-T-I-C-K, 5 letters, all lowercase. Please don't call it stick.sh, uppercase stick, PA3, etc. I will take off points. Call it stick, put it in a PA3 subdirectory under CSE224, push it over to GitLab, and I should be able to download it on the day that it's due. And as before, if you're pushing it over to Git and you decide, by Friday morning, you don't want me to grade it, push in a file called do not grade in that PA3 directory, and I will not grade it until you remove that file. So if you've been pushing things over and you decide, oh, I forgot to do such and such, if he grades it now, I'm going to lose 50 points, just push this do not grade file into the directory. push it over to GitLab. And then when I download at the due date, I'll see that do not grade file and I'll hold off on grading. All right, so what does this do? If you just say stick, it says, how many sticks do you want to play with? And I can say 20. So it shows me the pile of sticks. Oh, I have a typo. That should be a parenthesis. Hold on one sec. All right, I say stick. It says, how many sticks do you want to play with? I'll play with 20 sticks. So it shows me the pile of sticks and it says, I will take 1 stick, and now there's 19 sticks. And how many do I want to take? Well, I'll take 4. So that leaves 15. And it takes 1 stick. And so now there's 14. And I'll take 4 again because I've done this before. So there's 10 sticks. It takes 1. So there's 9. I'll take 4. That left 5. It takes 1. So now there's 4 sticks. And I'm going to take 4 sticks. And I won the game. So that's one possibility. If I play with 20 sticks and I don't know how to do that, I start taking sticks, and whatever I do, it's going to take the last stick. There were 3 left, it takes 3, and it says I won. While I'm playing, if I try to take an illegal number of sticks, like I say, I'm going to take all 19 sticks. It says pick a number between 1 and 4. I'm going to take 0, pick a number between 1 and 4. I'm going to take -22, pick a number between 1 and 4. So it'll keep asking me until I put in a valid number. And then it, continues. The other possibility is I can say stick, and I can say on the command line how many sticks I want to play with. So if I say stick 50, it'll play the game with 50 sticks. And we can keep playing this, and it'll win the game. So any questions about what the game is supposed to do, how it's supposed to play out, or what the requirements are? All right, so let me hop onto Canvas. And so up here in the beginning, there's this bash how-to summary of bash, ifs, loops, and arithmetic. And so this is the gold standard for this course. Let's see, if it starts with any amount of sticks that's not a multiple of 5, should the computer win all the time? Yeah, if you start with something that's not a multiple of 5, the computer should be able to win. Oh yeah, and the last thing is, if I say I want to play with 2 sticks, it just says, can't do that. But if I start with 21, there's no way I can win. Right, it doesn't matter what I take, it's going to be able to pick the last stick. All right, so this is your gold standard for how you write bash statements and bash scripts. So you're not allowed to use for loops in bash scripts for this course. Seems silly, but bash for loops have a totally different syntax from whiles, and it's just too easy to get confused. And you can always make a for loop with a while statement. So I'm not going to let you do for loops, but you can do while loops. And the syntax for a while is while space, bracket, bracket, space, condition, space, bracket, bracket. New line, do, new line, whatever statements you want in your while loop, and then new line, done. And your while loops have to look like this, right? It's picky, but if you get used to it, it's not bad.
Is it capital WOW or lowercase WOW?
It's lowercase. Kind of looks like a capital here. All right, your if statements, we'll come back to this other stuff. Your if statements are if space bracket bracket space condition space bracket bracket new line, then body of the if, and then new line phi. If you want an if then else, it looks like this. And if you want to do an if then else if, it looks like this. ELIF is the else if. So the condition you put in here depends on whether you're checking something involving strings or involving numbers. So if you're comparing strings, your real only options are equal equal to see if two strings are the same, or exclamation mark equal to see if two things are different. And you should always put the things you're comparing inside quotation marks, double quotes. And here I'm comparing the value of the variable x to the string hello. Here I'm comparing the value of two variables to each other. Here I'm seeing if the value of the string x is different from this string, and so on and so forth. You can also do this. You can throw an exclamation mark in front of a condition to negate it. So this is the same thing as if x is not equal to y. And if you're comparing numbers, instead of using equal, not equal, greater, less than, and so on, you use these tags, -eq, -ne, -gt, and so on. And so I could use this to say, well, the numeric value of x is the same as the numeric value of y, or the numeric value of I is less than the number 10, and so on and so forth. And don't use quotation marks when you're doing numbers. And then if you want to do more complex logic, you can do logical ands and ors by using the same thing we use in C, double ampersand, double pipe, and put that in between the conditions inside the brackets. So I'll bracket, bracket this thing, ampersand, ampersand, bracket, bracket that thing, would check for both of those conditions to be true. And those statements about conditions apply to if statements as well. And then the other thing is arithmetic. So when we want to calculate arithmetic expressions, we say $paren, and we put the arithmetic expression inside. And I'm going to stick to saying $x inside here. I didn't do that here, but this is fine. But you'll see me putting dollar signs in front of the variables inside here. I think that makes it less confusing, but this is also fine. And again, I'm going to say avoid using ++, right? It's slightly less typing compared to I equals I plus 1, but it can get you tangled up. And it can introduce a particularly hard bug to trace down. So I'm going to suggest just avoid that. We're not going to worry about this for now, checking to see if a number is legal, because for PA3, you can assume if the person's entering a number, it's always a valid number. So we're not going to worry about this. We can go back to this another day. And then there's just a bunch of examples down here on this last page of different kinds of comparisons we can do. And then a note that there's other things we can do in conditions, and we don't need to do any of this for PA3, but we can do things like, for example, see if a file exists, see if a file is readable, see if a file is a directory, and so on and so forth. And what we're looking at here is, a tiny little subset of everything we could potentially do in Bash as far as checking conditions, making loops, and so on and so forth. I'm trying to keep it intentionally as small a subset as possible, big enough that you can do everything you need to do, but not so big that there's 100 ways you can do it, and you might stumble across something that works but isn't actually correct. So those are the expectations, and I think this thing makes a handy cheat sheet for, you know, remembering syntax and things like that. And this is probably a good one to bring to the final exam with your notes, because it's you know, sort of a quick reference guide. Yeah, there are functions in Bash, and that's on my list to talk about today. So we'll get to that in a bit. All right, so questions on PA3. You can do this Bash stuff from the command line, by the way, and I did this a lot when I was first learning Bash, right? So I can say something like, you know, x equals 5. If bracket $x is greater than 4, then print working directory. And it prints my working directory, so this if statement fired. And I could say if bracket $x is greater than 6 or greater than 5, then print working directory phi, and it does not print my working directory. Oh, I did the wrong variable. Right, so here I know that x is equal to 5, and I said if x is greater than 5, print out the word bad, and it didn't print out the word bad. So you know, I can play around with these things. If I don't feel like writing an entire Bash script, I can just mess with them from the command line. Right, so here's an infinite loop. While 1 equals 1, do echo ha 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 done, and it, you know, my computer laughs at me now. And Control C, you know, gets you out of things. So you can mess with this somewhat from the command line, and that can be kind of a quick way to explore stuff. So, you know, x equals 17, echo $paren $x%5. This should give me the value of 17 mod 5, which should be 2. If x equals 20 and I echo this, it gives me a 0. So yeah, the percent operator works as a mod. All right, so let's talk ODPs. All right, so 402 was the ODP that was due Saturday morning. And the goal of this was to read one line of input from the user, treat it as an integer, and print out twice that value. So if you say good program and you put in the number 88, it prints out the number 176. And to do that was, you know, a couple of lines of Bash. So read X says, hey, let's read an input from the user and save what the user types in this variable X. And at that point, you know, X is still just a string. But then we do this thing, which says, hey, take the value of X, followed by a star, followed by a 2, and treat that as an arithmetic expression and evaluate it. So if X is 44, this looks like 44 star 2, and putting it inside the $paren says, evaluate that. And, you know, 44 star 2 is equal to 88. So that was ODP 402. And you want to make sure that you know how to do this. So some people got this to work by using the BC function, right? So I could say, you know, echo 44 times 2. And that gives me 44 star 2. If I pipe this into BC, BC will take this statement and evaluate it as an arithmetic expression. And that works, but we want to make sure that we also know how to do this, right? The $paren. so we don't have to pipe things into another program. All right, so ODP 403, which is due Wednesday morning. This is a bash script again. And in this case, it does the same thing as 402, but the number is taken from the command line. So instead of running ODP 403 and typing in a number after the program is running, you type a number on the same line as ODP 403. In other words, it's a command line input. So if I run good prog and I put 44 on the command line, it prints out 88. And you don't have to do error checking. You can assume that an argument is given and it is a valid integer. So if I do good prog negative 44, it'll print out negative 88. If I don't put an argument on there, who knows what's going to happen, but that's not one of the tests that you have to pass. So don't worry about that. Don't worry about this. Just assume it's being run with an integer and print out twice the integer. And there's no big trick to making this work. The whole thing is, argument equals $1. So when you run a script, if you put a command after the name of the script, that's available in this variable $1. And so I can take that and copy it to another variable, and then I can, multiply it by 2 and print it out. So is that doable? Cool. All right, and then tomorrow at 8:05 in the morning, the next ODP opens up, and that's ODP 404. And this is a little bit bigger of a script. This is a script that takes 2 command line arguments. The first argument is a word, the second is a number. And the behavior of the script is to print out that word however many times you specify. So if you say ODP 404 hello 5, it should print the word hello 5 times. And again, you can assume that both of these arguments are given and that the second argument is an integer. And in the ODP, there's some extra details here, which says, you can use a bash while loop. The syntax is similar to C. And here's a reminder of what a while loop should look like. And here's a sample while loop that acts like a for loop, right? So I equals 0, while I is less than 5. Let's output the value of I and then set I equal to I plus 1. And I can try this right here. I can just paste this in, and it prints out the numbers from 0 through 4. So that opens up tomorrow morning, and you can assess it after 8:05 in the morning. And if I tell it to print something once, it prints it once. If I tell it to print something 0 times, it doesn't print anything. If I tell it to print negative 4 times, it doesn't print anything. So it says up here, if the number is less than 1, your script shouldn't print anything. And this does not affect your program at all, but it's something that you should be aware of. If I say something like this, the double quotation marks tell bash all of this is one argument. And so when I pick up $1 in my script, it will be equal to this is fun. So your argument could have spaces inside it, but that doesn't make any difference to you. You're just going to take whatever $1 is and echo it. And this is going to be the number of times that you want to echo it. And if I run your programs with something like this, right? Bash will look at this and say, okay, what's 2 times 2? It's 4. And the second argument to good prog will be 4. The first argument will be, this is fun. So your program does not have to worry about any of these details. It basically just makes a loop that iterates $2 times, right? And each time through the loop, it just echoes $1. So any questions on that?
Yeah, I have a question.
Okay.
If you wanted to like print those out, right? Like this is fun, but not on new lines. How would you do that?
So there's a switch you can put on echo -n, which says don't print the new line at the end.
Oh, nice. Thank you.
And that's going to be really useful for PA3 because that's how you can print those vertical pipes side by side. So that's the trick there.
Awesome. Thank you.
Yeah. So let's make a test script here. All right, so I'm going to initialize I to 0. I'm going to throw some comments in here. So number signs start comments, right? And you can put them, anywhere that you want, and basically everything from the number sign on out is ignored. So I can put them on the same line as a statement. I can put them in the beginning. And people will stylize their code in different ways. Someone might do something like this. Right. And it's totally up to you. And there's whole art forums dedicated to ASCII art. You can Google ASCII art and find all kinds of things that people do in their code. And partially it's fun. It's a nice distraction when you're stuck on a problem. Just start, doing some ASCII art. Partially it becomes a signature. It can be something that, lets people identify your code quickly. But it's also functional, right? If I had a big long script with a few hundred lines and 2/3 of the way down, I had, some key function, and I mark it off with a block of comments like this. If I'm just scrolling through my code, it's really easy visually to pick up where that block begins. And if I do something like this in the beginning of each section of code or each function, it's a much quicker way to sort of, grok, to ingest and parse the code that I'm looking at. And so, this is individual choice, but you can develop this as your own style. So here's, basically a for loop. right? As long as I is less than 10, I'm going to echo the value of I. I'm going to increment it. And then when I'm done, I'll say goodbye. And the first time I want to run this, I need to change this permission bit to say execute. So I'll change mode to 755. And now I can say main 1, and it prints out my numbers from 0 through 9.
So
And
that
yeah,
actually brings up a question for me. So when you go to download these, right? And this might seem like an obvious question. Do you change the permissions yourself, or should we have them set as something before we push them to
you
GitLab?
definitely want those permissions set, right? Which they
Okay.
almost necessarily have to be because you're testing your code, right?
Right.
And you
So,
definitely want to test your code on the server. I
Yeah.
got some PA2s that probably worked great under VS Code or something, but did not work at all on the server.
yeah.
So you definitely want to be testing on Linux engrcs-com, which means they're going to be executable files. And when you push to Git, those permission bits are saved. So when I
Okay.
download, I'll still have that permission bit.
So is the 755 just fine?
Yeah, 755 is a good one.
Okay, cool. Thank you.
Your directories are read protected from the world. So even though technically this says, the world can read my file, people shouldn't be able to, because your directory itself is protected.
Okay, cool. Thank you.
Yeah. So bash is similar to C in that, we can embed loops inside conditionals, inside other conditionals, inside other loops, and so on and so forth. So here I've got a do loop, right? And inside here, I can check to see if the number is 7. Right? And this will work perfectly fine. So you come up with algorithms and then converting them to bash instead of converting them to C. That's the exercise in bash syntax and knowing how to write a while statement and where the spaces go and all that sort of stuff. And again, there are some things we can do that may work better than others. If I take out this space in the beginning of that condition, right, it's going to yell at me. But for certain values of I, it might not yell at me. It might actually work or look like it works. Because what it's doing is it's taking that $I and replacing it with the value of I. And so my statement looks like while space bracket bracket 0. And it's saying, I don't know what bracket bracket 0 is. But if I was something that translated to a space, this would still just look like while bracket bracket space. And I probably would not get an error. And I might think, oh, I don't really need those spaces. Nick was just being funny. But if you write other code without that space and I has a different value, suddenly your code might fail. Right? So I'm going to suggest you try to really stick to the syntax. And if you find you're doing something different, if you're putting a space in there, right, it's going to complain. Figure out why it's complaining, right? And say, oh yeah, I'm not supposed to have spaces in between those, and make yourself a note somewhere so that you stick to this syntax. All right, let's do a 5-minute break and we'll come back. We'll talk about the midterm because I want to make sure we make a few comments on that. And then we'll talk about bash functions and start digging deeper into bash. So let's do 5 minutes and I will see you back here in a few. So let's say 57. Come back at 11:03. All right, well, let's talk about the midterm. So the midterm is Thursday. It's during this regular class time, so it's not, something you just take anytime you want on Thursday. It's scheduled during the class. So it will start at 10 o'clock. I decided to give you the entire class period for it. I don't think you'll need more than an hour probably to do it, but there's no reason to add extra time pressure. And usually lectures after an exam aren't terribly productive. So I'm going to give you the entire 125 minutes on Thursday to do the midterm. So please show up for the midterm if you know other people in the class who aren't coming to Zoom. If you want to remind them to come to the midterm, that would be great. I strongly recommend being in Zoom during the exam because there might be, typos or things that aren't clearly explained. And if somebody pings me and says, hey, in question 7, you asked us to do such and such, but that's impossible. And I say, oh yeah, that should be an X instead of a Y. Well, I will post that in the chat board and I'll probably open my microphone and say, hey, question 7, that should be an X instead of a Y. If you're not in Zoom, I can't get that information to you. And you don't want to start emailing me a bunch of questions and having me try to negotiate that. So hop into Zoom. I'll keep my microphone quiet. Everybody else will stay muted. And but then I have a way to get to you if something needs clarification. And you have a really easy way to get to me if you have a question. Just send me a direct chat message. And I can answer your questions like that. So Thursday, 10 o'clock to 12:05. And so the format of the exam will be a PDF file that you'll download from Canvas, and it will have the questions on it. And you will want to type up or write up your answers and submit them as a PDF to Canvas. So there's some details around that. First of all, you can upload your submission to Canvas as many times as you like, and I will grade the last upload that you make before the deadline. So you can upload along the way, which is nicer than waiting until 12:04 and then trying to upload and realizing you don't have any way to create a PDF file, right? Which brings us to the next idea. Figure out ahead of time how you're going to do this. Don't try to figure it out Thursday at 10 o'clock. Figure out, how am I going to write my answers on paper, scan them, and save them as a PDF? And practice doing that. And if scanning a page gives you a 50 megabyte file, you're not going to be able to upload that to Canvas. Figure that out now. Don't wait till Thursday to make that discovery. But I suggest the best way to do this exam is to type your answers. So take your favorite plain text editor, and I don't want you using an IDE. I don't want you using VS Code. I don't want you using Eclipse or Visual Studio or IntelliJ or anything else, but a plain text editor. So Notepad, WordPad, VI is a great choice. Use that to type up your answers and figure out how to save those as PDFs. So most systems, if I open up WordPad and I type my answers in there and I say print to PDF, it makes me a PDF. But, if you try to do this with Word, it's a nightmare because Word will uppercase the first letter of each statement and it will mess around with your indenting and all kinds of things like that. So if you can put Google Docs into a verbatim mode where it just takes what you type directly, that's great. Do not screenshot though, unless you're absolutely convinced that it's a perfectly readable screenshot. Because if I get a fuzzy screenshot and I can't read it, it's going to be a 0 on that problem. But copy and paste is great, right? So here's some examples, right? So let's say this is let's say this is my submission. This is way longer than what a homework problem, test problem would be. But let's say that this is my code that I've written, right? I'm going to copy it. For me, I use OpenOffice, but you should be able to use Google Docs also. I'm going to go into Writer document, and I'm just going to paste this as unformatted text. And, there's my file. And I can say, save this as a PDF, and I can go into, this is question 1. And now if I go into that directory, I've got a q1.pdf, right, with my code in it verbatim. So in VI, I can be writing my code, and then for 2, I can say true. And for 3, I can say, make haha, and so on. And when I'm ready to submit, I take all of this stuff and I just paste this as unformatted text, save it as a PDF. I'll save it again as Q1. Right. And so, it's like a 15-second process, and I've got a PDF with my answers in it. So yeah, all the questions should be in one PDF file. And then you're going to upload that PDF file to Canvas. Yeah, that should be fine if you're using a markdown editor with PDF conversion. So you can use, Nano, VI, Notepad, Notepad++. But I do not want you using something that checks your syntax. I do not want you using something that does auto completion. I don't want you using something that generates code for you. Basically something that is a plain text editor would be fine. But just practice this ahead of time, right? And if I'm going to use Google Docs, have Google Docs open and ready for you before the exam starts. If you're going to save your Google Doc as a PDF, have a folder open already in the directory where you're going to save that PDF. And then, in Canvas, when you hit the upload button, drag from that directory or just go to that directory and so on. So streamline this process. And it can take, a few minutes to figure out the first time. So figure it out ahead of time and get as many things lined up as you can before the exam starts. Because with remote courses, there's always students who come to me and say, hey, it took me 15 minutes each time I uploaded a question, and I only had 2 minutes to actually do the exam, right? That's not my problem, right? That's a problem to figure out ahead of time. And you can email me, today or tomorrow if you're stuck on how to do this, and say, hey, I don't know how I'm going to do this, and I can give you some specific suggestions. But you want to figure this out early.
I have a quick question.
Mm-hmm.
So for the midterm, is it going to be are we going to open Notepad or whatever and write the code, write the answers to each question and save it under one big PDF? Or is it going to be segmented where it's this is question 1, turn that into a PDF, upload that to question 1, new thing for question 2, and keep doing that for all the questions?
You should upload one big PDF.
Okay.
But my suggestion would be, if you've done the first 3 problems and you're feeling good about that, save this as a PDF, upload it, and then go ahead and start working on question 4. And if you feel like that was a lot of work, I really don't want to lose that work, right? Save this as a PDF, upload it, and then go on to question 5, and so on. And you can keep uploading as you go. And then if something really goes fluey, if you lose your entire document or something like that, I can work with you on it, right? You can take your next file and say, hey, I uploaded the first 5, but for some reason I lost all of that. So here's question 6 on, right? And I can go back and I can see your previous upload. But I don't want that to be the intent. I don't want that to be the policy. I want you to try to have one PDF with all the answers in it.
Perfect. Thank you.
Yeah, you're welcome.
About how many questions is it?
So we'll talk details in a minute. I think it's 8 questions.
Okay.
But any other questions first about this business of writing up answers and turning those in?
You said that we could also save Notepad as a PDF. Is that possible?
I don't know if Notepad saves as a PDF. I know WordPad does. And I don't think WordPad gets too bossy with, making changes to your format. I know that, MS Word will be a horrible way to try to write code because of all the formatting it does. If you do get car parentheses C, it might change the paren C to a copyright symbol and so on and so forth. Notepad
Okay, so
won't save as a PDF, but usually in Windows you can say print and you can choose your printer, and one of the options is print to a PDF file. And that usually works really well.
So it sounds like you sort of recommend the Google Docs option.
Yeah, I haven't, or pasting, you should be able to paste into Word as unformatted text. But if
Okay,
you even
thank
hit
you.
an enter key after you paste this in, it's liable to do some formatting for you. So try whichever one is your preferred option for going into a PDF, and just make sure it doesn't do anything quirky. But if you use Notepad++ or Notepad or WordPad or something like that, you should be able to print to a PDF from Windows. Cool. Okay, and on a Mac, someone says you can use TextEdit, make it a plain text file and save directly as a PDF. Your other option, like I say, is to write things out by hand. And if you've got a really good scanning setup going, that can be great. But scanners are usually temperamental. Taking pictures with phones usually makes really big files and they tend to come out fuzzy. And so that's probably not your best bet. And typing is probably faster than writing by hand, and it's easier to make changes to your code and so on and so forth. All right, the other thing about logistics is you're not allowed to use, syntax checking editors, things that autocomplete. You're not allowed to hop onto the server and type your code into a file to test it, right? And I've had people do this in the past, even when I'm completely clear saying, you're not allowed to use the server, etc. People still do it. And so if things like that happen, we may have to go to something like a lockdown browser setup. And I don't want to do that because I think that's just more complication and more stress and so on. So, write the code yourself and don't use any tools to test your code or to generate your code other than yourself. All right, so clear on the logistics. The other logistic is there's an honor statement in the beginning. Question 1 is an honor statement. And you don't get points for signing the honor statement, but if you don't sign it, you lose 100 points. So in the very beginning of your answers, you need to type the words honor statement : followed by your full name. And that counts as your signature, and your signature indicates your acceptance and understanding of the honor statement. And I can pull this up for you in a second.
One more quick question for you, Nick.
Yeah.
So you said that the server is like not accessible during the test, so we can't like go back and look at our old code or anything like that.
Yeah, if you want that stuff, you want to download it ahead of time.
Gotcha. Thank you.
All right, so here's the beginning of the exam, right? So open book, open note, no other resources. You may use a simple text editor to type your answers, save them as a PDF. So the honor statement says, by taking this midterm, you agree to use no resources other than your notes, including your own code and your textbook. You may not use any online resources, web pages, servers, etc., and or consult in any manner with anyone other than your teacher. You also agree not to assist others in the exam in any way. And so question 1 will say, type the phrase honor statement followed by your full name, and it can be typed if you're typing your answers to signify your understanding and agreement. And so that's got to be in there. If you want to download things from your GitLab repo, then that's okay. But you have to do that before the exam. So I don't want you using a web browser for anything other than getting to Canvas or Google Docs if you're using Google Docs. So this is where end user license agreements end up being 50 pages long, right? Because if I try to spell out every possible contingency in every detail, it's going to end up being a 50-page honor statement. The intent is I want you to do your own work. I don't want you looking up information through websites. I don't want you trying out code on the server and so on and so forth. Yeah, if you're going to use VI, you can go ahead and do that on your own Linux setup. I'm not going to lock the server, but if I see anybody from class logged into the server, it's going to lead to a conversation later on about what were you doing there and why were you there. So, you should have either a virtual box or your own Linux laptop or something like that, so you can run VI on there, or, just use a plain text editor. All right, so details of the midterm. So I think I set it up to 8 questions, which doesn't really tell you anything about how hard or how long it is, because there are, very short questions like true, false, and there are very long questions like write a complete program to do such and such. So it'll be a mix of questions that ask you to write code and questions that ask you to write some statements or some commands or answer some questions about commands or statements. The coding questions will all be in C. So I'm not testing you on bash coding yet because we just started that. So the coding questions are on C. Some of the questions will say, write a complete program, which means number sign include, void main parentheses, blah, 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 the whole 9 yards. Other questions will say, write a function, which does such and such, in which case you don't need a main program. You don't need the number sign include. You don't need all of that stuff. You just need to write a function. So it's important to be clear what the question is asking you to do. If I ask you to write a function that takes 2 integer arguments, adds them, and returns their sum, that's like, 2 lines of C. Unless you start writing a main program and asking the user to enter numbers and parsing it and checking for parse errors and all this kind of stuff to call your function, which I'm not asking for. So be really clear what the question's asking. And if you're not sure, send me a message in chat and say, hey, for question whatever, do we need a whole main program or just the function? So there'll be questions that use the programming skills that you've demonstrated in PA1 and PA2, or that you should have, from prior courses. There can be questions about make-files, questions about Git, questions about GDB, questions about basic Unix commands. All of these things are potential questions. And like I say, I'm anticipating it's not going to take you 2 hours to do this or anything close to 2 hours, but I'll give you 2 hours anyway. Not all the questions are worth the same number of points. So when you first get the exam, it's probably worth going through and looking at the questions and getting an idea of what they involve and looking at how many points they're worth. If there's a 5-point question on Git and you don't remember anything about Git, don't spend an hour staring at the question, racking your brain, trying to remember how you do something in Git, right? If it's only worth 5 points. If there's a C programming question that's worth 20 points and you feel like you can do it, go ahead and do it, So budget your time and follow a plan. For some people, doing the stuff that's easy first, it makes the most sense because you get a lot of points and you get that out of the way. For some other people, right, if there's stuff you know how to do, sometimes it feels better to do the stuff you're not sure of first. First, get that out of the way and then relax and do the stuff that's easy to write. So everybody has their own test taking style and approach. So whatever's going to work for you. So for the answer sheet itself, right, what I'd like to see at a minimum is, question 1, and then your answer for question 1, question 2, and your answer for question 2, and so on. If there's a question with multiple parts, right, 3A and your answer, 3B and your answer, and so on. But I'm not super picky about the format of that.
Do they have to be in order though? So like if we decide that question 2 is going to be too hard, we can go 1, 3, and then at the end put 2 if we have time to work on it, kind of thing.
Well, if you're doing this in an editor, right, you can go back and you put question 2 between 1 and 3, for example, right?
I guess so.
And
only
if
you're writing this on paper, does that matter?
If you're writing on paper, I would do each question on a separate sheet, maybe. If it's too hard to do, if it's absolutely necessary to do the questions out of order on the PDF, I will work with that. But my preference would be to have them ordered. But if that's going to cost you a lot of time or concentration, then don't worry about it. I'll reorder them myself. But if you do that, you've got to make really sure that I know that there's a question 2 at the end of your PDF, and have a big 2 there instead of something that just looks like it's part of the answer to question 7 or something. As far as syntax, I'm not going to be super duper picky about syntax. If you missed a semicolon here or there, I'm not worried about that, right? But if you don't know how to write argc, argv on a main program, that's going to cost points. If you don't know that you should use curly brackets in the beginning and the end of a function, that's going to cost points. So the stuff that you should have done a number of times already, I kind of expect you to be able to do, whether you're typing into an editor or writing on paper or whatever. But if there's something you forget to do, I'm not too worried about that. Like a stray semicolon, or if you have some big if statement here with a bunch of parentheses and maybe you're missing your final closing parentheses, I'm not worried about that, right? Because we have compilers that'll do syntax checking for us and so on. And this is kind of an artificial way to write code, to do it in the absence of being able to compile it and test it like that. but try to get the main aspects correct.
Do you want us to include the libraries that we'll use for our functions in the code, like standard IO.h and all that?
If you're doing a function, don't worry about it. If you're doing a main program, include them.
Okay, cool.
But if you're writing a function and you're using string length, I'll just assume that you've included string length.
Cool. Thank you.
Yeah. All right, other questions?
Yeah, is there any way you could give us a little bit more on what exactly we should be brushing up on?
Go over your programming assignments and ODPs.
Okay, so
And
programming
if you
assignment-
understand the concepts involved in those, you should be fine. I'm not going to ask you to do ODP 405, for example, right? I'm not going to ask you to write a stick program in C or a word index program. But if you're comfortable with the concepts that you used in doing those things, you shouldn't see any surprises on the exam.
Okay, awesome. Thanks.
The function questions, I'll give you the prototype for the function and tell you what the function should do. I don't think they're going to be as complex as, some of the functions on PA2. So, like my get car did a whole bunch of things, and it took, a paragraph or two and a lot of discussion in class to explain what it was supposed to do. I'm not going to do anything nearly that complex, right? Your function will generally be doing, one or two things, and it should be pretty self-explanatory with a few sentences on the exam.
You probably already said this, but like, let's say you do that, right? Like you give us a function prototype and all that stuff. Should we be doing that like we did with the ODPs, where we just put the declaration and then definition, or do you want like a main with those as well?
If I'm asking for a function, you don't need a main, you don't need the prototype, you don't need an include file, you just write the function.
Okay, cool. Thank you.
Yeah, you're welcome. So yeah, best way to study, go over your notes, right? So the things that we've talked about, go over the code that you've written for ODPs and for programming assignments, and just make sure you understand the concepts involved in those. If you manage to, take the new line off of the end of a string, but you don't really know why that worked, you just did it because we wrote it in class and you tried it and it worked, but you don't understand why, go back and think about why it works. Go back through and do some of the the index calculations for, what's the position in the string of the new line, what's the position of the null terminator, where in a string is the last character located relative to what string length says, those sorts of things.
So as long as we're solid on the ODPs and programming assignments, we should be pretty much good to go.
I think you should be pretty much good to go. Yeah.
Okay. Thank you.
And again, you're not going to see, the same things that you've already done, but the questions I ask will involve similar concepts to what you've been using. Definitely review make files, make sure you're up on Git. So I'm not going to ask you about, git remote add origin, blah, blah, blah. But I want you to understand git add, git commit, git push. Know how to do those three and what they do. Make files, you should understand what's inside your make file, what a make clean does, and so on and so forth. GDB, if I ask you about GDB, we haven't really done a whole lot of hands-on use with the debugger yet, but I want you to know a few basics about it. And there's actually a guide on Canvas. It says short GDB summary. And the only thing I really need you to know at this point is, using the -G switch when you compile to put in GDB support, saying GDB program name to start GDB, running on your program. And these commands here, so start, begins the debugging process. List shows you the code. Print lets you print the value of an expression. Step and next let you step into or step over a function. Break, I can say break and put in a line number or function, and the debugger will stop when it gets to that point. Continue continues from where we stopped, and X lets us examine memory. And don't worry about any of the rest of this, right? Because these are the only ones we've talked about and the only ones we've played with in class so far. So those commands plus the X command just to look at a memory location. And that's a more than sufficient understanding of GDB for this part of the course. All right, good to go. Cool. All right. So let's we've got about 30 minutes left. Let's dig more into Bash and look at some stuff that will tie into PA3. And so one of these is the question of functions. And in a Bash script, we can write functions just like we do in a C program. And a function can be used to take a set of common behaviors and bundle them together. And in Bash, we make a function like this. We can say function, give it a name, curly bracket, and list all the Bash statements we want executed inside that function, and then closing curly bracket. So I could do something like this. Function now. All right, so I've just written a little function, and if I say now, it will execute this echo statement which says the date is, and remember, if we put a command inside back quotes, that gets replaced by the output of that command. So now it should say the date is, and it should show me the date and time, and then your current directory is, and it should show me what directory I'm in. And this is a function inside this bash session that I'm running right now. So if I say now, it tells me my date and my directory. And if I go into a different directory and I say now, right, it shows me my new directory that I'm in. And this is different from running a script, right? This is a function. It's something that the bash shell is remembering, so that when I type in the name of that function, it does this business. And if I start a new bash shell and I say now, it has no idea what I'm talking about, right? So this function goes away when I exit the bash shell, or if I start a new bash shell, it simply doesn't exist. And so we can give arguments to functions to change what they do. So let's say I want to, I don't know, let's make a function that just, adds 1 to a number. Like I'm bored and I just want to increment functions. So I'm going to make a function called increment. So inside a function, if I type the function name, like name, followed by something, I can get to this something with this $1, just like we do in a bash script. And so my function could say echo $1 + 1. And so if I say inc 17, it shows me 18. So we can use functions to, perform a series of instructions repeatedly instead of just typing those instructions everywhere that we want to have them happen. And we can pass values to functions. And so this is one way to modularize our code when we're writing scripts. So in PA2, a big part of that exercise was about modularizing our code, breaking the overall algorithm into a series of smaller tasks. The task of getting and conditioning a character of input, the task of taking conditioned characters and building a word, the task of taking a word and tallying that we've seen this word one more time. And we made different functions for each of those. So in PA3, one of the things we're going to need to do multiple times is print out how many sticks there are. And we can do this echo -n to print a single bar. And if we make a loop which echoes this, 15 times, we'll get 15 pipes next to each other. And that could be a cool thing to put into a function. We're going to need to do some calculations to decide how many sticks the computer wants to take. And so if num sticks is the number of sticks left in the pile, we want to do something like this. Right, this would tell us how many sticks the computer takes, unless this turns out to be 0. So we could do something like take equals this, but then we need to say if take is equal to 0, let's set take equal to 1. And so we're going to have, several lines of code whose whole purpose is, given this many sticks, how many sticks should the computer take? Well, that might be nice to throw into a function. And so, part of the reason of writing functions is to simplify other pieces of code, to take all of the complexity of describing some behavior in code, and in bash, that can be particularly cumbersome looking, to take all of that complexity and hide it somewhere. And also to let us test. If I write a function which should take a number of sticks and tell me how many sticks the computer takes, I can test that without anything else in my program. I can say, okay, determine CPU move 20, and it should come back and say 1, and determine CPU move 22, and it should come back and say 2, right? So I can develop piecemeal, right, step by step. So all the stuff that makes us want to write functions in C applies in bash as well. And so we can do functions like this, but we can also write scripts, right? So I could make a script called increment. Oops. I'm in the wrong directory. Let me call it inc2. So I can make a script called inc2 which basically takes a command line argument, adds 1 and echoes that. And so I can say inc2 and give it a number, and it'll give me back the number +1. And that's not a function, right? That's just an entire script. The disadvantage of scripts is, you need to have all of those scripts in your current directory. But if you want to do that for PA3, that's totally great. Just make sure all of those scripts are in your GitLab repo. And then, I could write a script whose whole purpose is to take the number of sticks left in a pile and tell me how many sticks to take. So let's do some sample code. And let's play with prime numbers. So I want to make a script called isPrime, which takes some number and tells me whether or not this number is prime. And I want to do this in bash. And what's the most straightforward way to tell whether or not a number is prime? No idea. Divide what? See if it has factors that aren't 1 or itself. Test for divisibility with every number less than its square root. Perfect. So to tell if num is prime, let's just see if it's divisible by 2, divisible by 3, divisible by 4, and so on. And I don't want to deal with square roots, so I'm going to see if it's divisible up to num minus 1. And this is something we can put into a loop pretty simply. So let's make an isPrime function. So I'm going to save the number we're testing into another variable called num, because $1 kind of looks weird sometimes when we try to use it in arithmetic and such. And so let's check for divisors. So I'm going to say divisor equals 2. And I'm going to do a loop while divisor is less than num. And see if num is divisible by divisor. So I'm going to do that by saying let's take our number modulo our divisor. And if that's equal to 0, that means there's no remainder when we take num and divide it by divisor. There's no remainder and num is divisible by div. And I'll print out a message and say the number is composite and one of the factors is, and I'll print out the divisor and I'll say exit. And I'll keep looping through all possible divisors. If we come out of that loop, it means we didn't exit, so there was no divisor. And I'll print out the word prime. And if I just fall off the bottom of a script, it's the same as saying exit. So it's kind of like returning at the end of a function versus just hitting the closing curly bracket. So I can make this thing runnable and I can say isPrime 7, and I got syntax errors. So it's saying line 13, syntax error near unexpected token fee. So let's go to line 13. And why doesn't it expect the word fee? Because I didn't say then. So we'll fix that and we'll try isPrime 7. And this is the mistake I always make with while loops. It's running forever. It feels like an infinite loop. and my while loop is supposed to exit when divisor reaches num. I forgot to increment divisor. So let's go ahead and do this. So now I can say is prime 7 and it says prime, and is prime 9 says it's composite, and there's a factor of 3, and 100 has a factor of 2, 101 is prime, 1001 has a factor of 7, and so on. All right, so this is checking a number for primality. And it's a nice little self-contained script. And we can exercise it and, you know, see if it works. And once we know that this script is working, we can use it inside other scripts. So suppose what I want to do is print out a list of prime numbers. So I'm going to make a new script called print primes. And I'm going to say, well, num is less than 1,000. I'm going to say if the number is prime, let's print it. And then I'm going to move on to the next number. And I'll say goodbye. So the question here is, how do we tell if the number is prime? So one thing I could do is say is prime $num. And this will sort of tell us what we want, but not quite exactly. So if I do this, and I say print primes, well, I get a bunch of output. And basically, you know, if I run this into more, so this is telling me 2 is prime, 3 is prime, 4 is composite, 5 is prime, 6 is composite, 7 is prime, 8, 9, 10 are composite, 11 is prime, and so on. So, I mean, the is prime function is working. But what I really want is I want just a nice printout of all the prime numbers, and I don't want to see anything for the composite numbers. So how do we run this is prime function and figure out from that whether the number is prime or not? And the answer is going to be, we're going to use these back quotes. So this idea of putting a command inside back quotes, which says execute the command and replace this with the output produced. So I'm going to do the following here. I'm going to, instead of saying is prime num, I'm going to say result equals back quote is prime num. And I'm going to note that if the result is the word prime, then num is prime. Right? Because that's what our is prime function does. If we give it a number and that number turns out to be prime, it prints out the word prime, just, you know, by itself on a line. So these back quotes are going to capture that output and save them in this variable result. And now I'm going to say if bracket bracket $result equals quote prime, then echo num. So everybody see what's going on here? And this is the most generally useful way to capture results from a script or from a function.
So can I ask, in that comparison where you're comparing result, I'm guessing that's some number, and then equals to the string prime, how
Mhm.
exactly does that work? Like, why does
So
comparing
let's
that number? Sorry.
so let's just do this here, right? So if I say is prime 7, it says prime. So suppose I say, you know, r equals back quote is prime 7. Okay, so it executes the script with an argument of 7, and the output generated by the script is now saved in R. So if I echo $R, it's the word prime.
I see. So it's not technically, so it's taking the number and then comparing it to the output of the function, essentially.
It's just capturing the output of the function. So if I say is prime 9, and I set R equal to back quote that, and then I echo $R, it's this string composite factor equals 3,
Mhm.
which is the same thing as if on the command line I had simply said is prime 9. So it's executing a script, but instead of
Oh,
having that script print output to the screen, it's saving the output in this variable. And then we can do something with that variable, such as compare it to a string to figure out what the script was telling us.
oh, I see what you're saying. It was I guess for some reason I thought result would be a number, but because of the back quotes, it's just saying result equals prime
Yeah, exactly.
or not. Awesome.
Yeah,
Okay.
it's setting result equal to whatever that output would be.
Cool. Awesome. Thank you.
Yeah, you're welcome. So yeah, echo is basically a way we can do returns of values in C. It looks like a print statement, but if we run our bash command in back quotes, it effectively makes that output available to be saved or processed by whoever executed the script. All right, so in this case, we'll see if the result is the word prime, and if it is, we will output the number with an echo statement. Otherwise, we won't do anything. We'll just go on to the next number. So if we do this and we say print primes, we get a nice list of prime numbers, starting with 2, 3, 5, 7, 11, and so on. And here we can use that -n switch to print out the number followed by a space, but say don't put it on a new line, just put it next to whatever the last output was. So if we do this, then we get a nice list of primes side by side. And if we don't want that goodbye to come out next to the last prime, we can just put a blank echo statement in the beginning. So that when it's ready to say goodbye, first it says echo to move to a new line, since our last echo statement did not move to a new line. And so now we get our primes, and then it says on a new line goodbye. Yes, exactly. So this will be a powerful tool for us. And when we get to PA5, you're going to use this a lot, because PA5, we're going to be making GUIs, and we're going to use bash commands to generate GUIs, and we'll capture the result of those by using this back quote business. All right, so other questions about that? Is there any difference between using a function or a bash script? Yeah, so bash scripts, for one thing, you know, they're files. So I have my print prime script, I have my is prime script. And so inside print primes, if I'm going to say is prime, that script needs to be in the same directory, or I need to put a path in here that tells me where I can find that script. And then if I want to use this print primes script somewhere else, I need to make sure that is prime is available as well. And so that's a little more management. Whereas if I used a function, the function would be defined up here, right? I could make the function for is prime in the beginning of this script, and then I just have a single file that would contain, you know, all of the code for is prime and print primes in this case. Functions can be nice though, because like in your .bash RC, you could define a function that does something useful, like that now function we had. And I don't have to specify where that script is stored, right? It's a function that's in the memory of bash. And so I can just invoke that anywhere. Back quotes allow you to capture the output. If you don't have the back quotes, then we've got that earlier version. Well, if I do this, result will be the string is prime space followed by a number, right? And it's just a string, and it's never going to be equal to the string prime, because it's always going to be ISPRIME space and a number. So the back quotes cause it to actually execute. Way to run a function defined in one bash script and another bash script. I'm not sure about that. It depends. So if I make another bash script that only contains function definitions, I could include those by saying source. And source is different from just executing a bash script. Source actually says, read the contents of this file and execute it in my current bash session. So so for example, if I echo $x, it doesn't happen to have a value. Let's make a function called set x, and let's set x equal to 42. All right, so if I say set x and I echo $x, it's not set, right? Because when I say set x, a new bash instance is created, and it's that new bash process that's executing this script. And when the script exits, that bash goes away and we come back to this bash. And in this bash, x was never given a value. But if I say source set x, that says, hey, in this current bash, read the contents of set x and execute each of those lines. And so one of those lines said x equals 42, so now x has a value. So if I made a file that defined a bunch of functions, I could say source file name, and it would act as if I had typed in all those function definitions. And so that's a nice way to pull those in. Cool. Source is nice when you make changes to your bash RC and you want to execute them. If you just say .bash RC, it doesn't change anything. But if you say source.bash RC, it's just like what happens when you first log in. Those statements get executed in your current bash session. Yeah, so it's very much like an include statement. It basically pulls it into your current bash. So yeah, that's one reason why variable names don't cause problems with multiple scripts, because they're local to the script that's being executed, and then they don't exist once you exit that script and come back. All right, I will call that good there. So, office hours tomorrow morning from 8 to 9:45. If you've got any questions on PA2 or PA3, that's a good time to do it. Usual office hours Friday morning. Midterm on Thursday, so Thursday 10 o'clock. I will open up a new area on Canvas shortly before 10. So if you've got Canvas open, you'll want to refresh it once 10 o'clock hits, and that should open up the question with the downloadable PDF. All right, try making PDFs and try to send me an email today if you're stuck on that, right? Try not to leave it till the last minute. And I can give you some ideas for tools to try using and ways to paste text unformatted and so on and so forth. So figure out those details, and then you don't have to worry about them on the exam. You can spend the exam writing code and answering questions. All right, cool. I will catch everybody next time then. Hope you all have a great rest of the day. And thank you.
Thank you.
Thanks, Nick.
You're welcome.